All right, guys, so I'm going to do my notes, so I thought I may as well record it so you can follow along. We're moving on to 6 systems of linear inequalities. You can graph the solutions of a system of inequalities in the coordinate plane. The graph of the system is the region of the graphs where they overlap. So a system of linear inequalities, we're moving away from inequations, are 2 or more linear inequalities. A solution are any ordered pairs that make them true, just like it has been, except FYI, like on a lot of these, it's going to be a million, like an infinite amount of ordered pairs that makes it true. I'm only going to teach you one method of solving, and that method is graphing. And the answer is where the shading overlaps. It's every single point where the shading overlaps. So let's just get straight to it. So part 2, I have an example of what this looks like for you. So the first thing you do, I think the first one I did on Desmos, I made it red. So you can see that it has a y-intercept. Okay, so wait, sorry. This is a system. See how it's like together? That's a system. And we're trying to figure out what points, what x, y points make it true, okay? So we graph it. The first one we graph is the red one. We go down to -3, up 2 over 1, up 2 over 1, up 2 over 1. It's a broken line, and we shade. Then the next one, I think is blue. We solve it for y, so we get greater than -2x plus 2. Let's see, we got go to 2, and it goes down 2 over 1, down 2 over 1. And again, we use another broken line because it's not equal to. Now the answer to the system is when those two pictures get merged together. So if you can say this one here, this one right here, is where the red one and the blue one kind of come together. And you see this purple area? This is the overlapping area. This is where all the solutions are. So for example, 9, 2 is one of an infinite amount of sets. Any point inside of here is a solution. Okay, and what it means to be a solution is that anything inside of there will substitute back into these. You can do 9 and 2, 9 and 2, and you could get like a true solution or a true statement on both of them. Anything in the blue area will only make the blue the second equation. So this is for the blue only, the second equation only. And this one, the red one, is for the red equation only. This purple area, any point inside of there satisfies both inequalities. So you should really only answer with the overlapping together. You really shouldn't include all 3 of them. But sometimes people are picky about that. Sometimes they're not. The only thing I couldn't get Desmos to do was this was a broken line. I'm not quite sure why it didn't want to graph that for me, but that should be bounded by a broken line. And of course, as always with arrows, but I can't force that on Desmos. Okay, so your final solution should kind of eliminate anywhere else where it's not shaded. Let's just try it together, see how we do. We'll stick with the blue and the red theme. I have a little bit of review in here for you because I know sometimes the red one's hard for people to graph. I had to redo this whole problem. I'm so mad at myself. I forgot when I divide by negative to flip my sign. So, and just so you guys know, I'll actually undo that so you guys can see my big mistake. This is the wrong answer. I want you guys to know how I knew I did it wrong. I was going through and I was checking it and I was like, wait, that's a false statement. So that was how I realized, like, I made a huge oops. So that's unfortunate, but lesson learned. And good thing I tested a point, right? So we get -3y, and we're going to carry that 4 over to the other side. You get -4x plus 17, divide by -3, flip my sign so I don't do it wrong again. 4 over 3x minus 5.6. Sorry, that's kind of written silly. So go down to -5.6 and go up 4 over 3, up 4 over 3. That's good enough. I am now going to get my broken line tool because it was not equal to. Connect them. I'm going to extend that. Grab back my regular solid pen. Pause the video, please, if I'm going too fast to catch up with me. And this says less than. Remember, we had to flip our sign. So I'm going to shade everywhere below my blue line. So everything here satisfies the blue equation. Now the other equation is just a y value. And because we've studied that, that's just a horizontal line where y is 0. It's a solid line, and I'm going to shade above it. So there's my solid line. I'm going to shade above it. And my answer is where the shading overlaps. So I'm going to grab purple, because red and blue make purple. And the shading is right in this tiny kind of like triangular area. Now, I'm going to erase the red and the blue because those aren't actually part of my answers. Well, like the red and the blue where they intersected were my answers. But I needed to satisfy both inequalities. So, for example, let's try 7 and 1. 7, 1 is a point inside of there. So, any point to test it. So, we do 4x, so 4 times 7, minus 3 times 1. And that has to be greater than 17. So that's 28 minus 3, which is greater than 17, which is 25, which is greater than 17. So this is true. And then for y is greater than or equal to 0, let's see, the y value is 1. So y is greater than or equal to 0, so that one's true as well. So you can see I shaded in the right spot because it satisfies both of the inequalities. All right, let's go do the next one. Be a little more careful. All right, I actually had to redo this problem as well because I had a couple of things wrong, but you should have it right on yours. So we're going to graph the blue one, we're going to graph the red one, and then the third one, I'm going to graph, I'll actually make it, I think I can do green. Hopefully that'll work. All right, so for the blue one, hopefully you notice it's the exact same as the one next to it. I must have wanted to save some time. So if we solved for y, we would end up getting 4 over 3x minus 5.6. And we're going to graph that literally the same way we did on the last one. We were going to go down to negative 5.6, go up 4 over 3, up 4 over 3. Connect using a broken line. Shade, what did we decide on this one? Shade, I think it's below. Yes, shade below. All right, now I'm going to grab my red. This is a vertical line where x is positive 6, and it is broken because it's not equal to. And I need to shade below it, so less than it, so everything over here. You can already see where the red and the blue are coupling up, right? Kind of darken that area in. Okay, now I'm going to grab my green. I'm going to go down to negative 9. And my slope was 0.75. In other words, hopefully you guys know that that's really 3/4 for your slope. So we're going to go up 3 over 4, up 3 over 4. And is that a broken line as well? Did I make I made everything a broken line? Of course I did. Okay, so we're going to connect using a broken line. Oh, not with white. Why did I pick white? Green. Okay. Well, I'm going to really extend that. You might want to extend your blue one too. I'm not sure if you guys can do that or not. I'm actually going to extend my blue one just so you know. Okay, look guys, I am going to grab my blue line. I am going to extend it because I really want it to intersect. Okay. Now the reason I'm extending it, guys, is because you really should go to the points where they intersect because, let's see, what are we doing here? Does this one want to shade above? So I'm going to get my green highlighter. I'm going to shade above my green line. Where do all 3 of them come together? Can you guys see it? it would be in this area here. I'm going to highlight it in black. So it's kind of like this little funky area here. Okay, I'm going to get rid of all my other weird highlights. Boom, boom. And I made that shading a little bit big, didn't I? It's kind of like in there. I can't be too pinpoint accurate with a highlighter, but it would like be this area too. Kind of like a neat little triangle there. So it's where everything intersects. Now let's grab a point from inside of there. Maybe I'm going to grab -2 and -9 because that seems to be in there. -2, -9. And let's see if that works. -2 and -9. -2 and -9. 4 with -2 minus 3 with -9. And that's got to be greater than 17. So it's -8 plus 27 is greater than 17. -8 plus 27 is 19. 19 is greater than 17, so that's good. For x is greater than 6. What point did I pick? Oh, less than. That doesn't say greater than. Sorry, I was going to have a moment. What was my x value there? My x value was -2. So let's see, let's put -2 in there. That's true. And now what was my last one? Green. So it's y is greater than, it was 0.75x minus 9. And what point did I pick? I picked -2 and -9. So I picked -2 and I picked -9. -9 is greater than, that's going to be -1.5 minus 9, and -9 is greater than -10.5. Yay, that's true, which means I shaded in the right area. Whew. Okay, that one was a little bit of a challenge. Okay, maybe for class, maybe what I'll do, not for you guys, but maybe I'll change that just a little bit to be maybe -8 for my students, maybe -7. I might change that. So I might fix this, not for you guys watching the video, I might fix this in my notes to be -7. Not for you guys, the whole thing, it'll end up working out, don't worry. Okay, now, Rand equation represents this following. So for the blue line, I see a y-intercept of 1. So in y, we're doing like y equals mx plus b. Y-intercept of 1, and I see a slope of up 1 over 1, up 1 over 1, up 1 over 1. So 1x. It looks like it's shaded above the blue line, and the blue line is solid. And I'm just going to get rid of that 1 because it annoys me. Now let's do the red one for a system. So I got a 1, 2, 3, 4, 5. I have a y-intercept of 5. My slope looks like it goes down 1 over 2, down 1 over 2, down 1 over 2. And it is broken and shaded below the red line. So there's my system of equations. This one, my blue line, let's see, I have a y-intercept of 3. And I have a slope of up 1 over 2. It is solid and shaded above. And then I have an x line with -2. It is shaded to the right, so it's greater than, and it's not equal to. So that's that system. Application, you're planning to do work after school. You can spend 6 hours daily playing basketball and doing homework. So basketball and homework. You want to spend at least 2 hours playing basketball. You must spend at least a half hour on homework. What is the graph showing how you can spend your time? Okay. I'm going to let x be hours playing basketball. I'm going to let y be hours doing homework. I'm going to shrink that down. Together, I have to spend less than or equal to 6 hours. So basketball. I want to spend less than 2 hours playing. You're going to spend less than 2 hours playing basketball. So that's basketball, less than 2 hours. And I must spend at least 1.5 hours doing homework. Okay, so now we're ready to graph. So hours playing basketball is my x-axis. Hours doing homework is my y-axis. The first graph, my blue highlighted graph, whoops, I forgot I changed my highlighter to be so silly. Okay, that's going to be y is less than or equal to negative x plus 6. I think I can count by ones. 1, 2, 3, 4, 5, 6. Down 1 over 1, down 1 over 1, down 1 over 1 until I reach the bottom. And this will be shaded below. All right, that one's good. Then I'm going to do this one in red, okay? So I'm going to go to where 2 is. Broken line. And that says less than, so shade to the left. I'm trying not to get into the negatives when I shade. And then the green one. Okay, 1.5 is like here. And it says, okay, great. So I'm going to shade that right here. I'm going to go straight across. It was solid because it was equal to. And I do believe it said more than 1.5, so I'm going to shade everything above my green line. You can keep going, but now what we're going to do, guys, we need to figure out where in the world like all of that intersects. So I need to know where the green, the purple, and the blue. I hope you see it, where green, purple, and blue come together is this area right here. So above the green, that area right there. I'm going to erase all the other messies. That's my answer set right there. Okay? So anything in here, how do we say that? Let's go ahead and point. Okay. Any combo of time in here is feasible. So you can, for example, hey, come get yourself. For example, you can do 1 hour of playing basketball and 2 hours of doing homework, and that would satisfy everything. Just so you guys know, anything on the red line, not an answer. Okay, because it's broken. Anything on the green line and the blue line is totally fine. So anything, any combination inside of there, but excluding the broken line, because it says you want to spend less than 2 hours doing basketball. So even like right here, that would be okay. What would that be? That would be like maybe 1.9. Just for an example, this would be like 1.9 hours playing basketball, and what is that? 3 hours doing homework. So anything inside of that shaded area satisfies that. Okay. There are some special cases. I do know I'm going fast again. You can slow this video down or pause it. Do whatever you need to feel comfortable with it. Rewatch it. Let's graph this. So let's go to -3 and go up 1 over 2, up 1 over 2. It is a solid line when we connect. And they want us to shade above it. So everything above. Now for the red one. Notice I like deliberately, on purpose, I gave you the same thing. So the red line follows the blue line, but the difference is that it's broken. So when I connect these this time and I have a broken line, it's going to be a little bit different. It's going to feel like it's an infinite solution because this one says less than or equal to. So it would be everything under here. So the question is, where does the blue and the red come together? And you might say, oh, everywhere on that line. Well, you would be wrong, okay? So the question is, where does the blue and the red come together? Nowhere. The blue and the red never intersect. Not even on the line, because the red line is broken. So that means this is a no solution graph. Now, if the red line was solid, then the answers would be only on that line. So if you want to make that no, so it's like, if the red was solid, The answers are on the line only. Okay, so just want to make sure that you see there could be a no solution. Let's do this one. Blue, so we go to +1, up 1 over 2, up 1 over 2. Solid line, connect. Solid line. Up 1 over 2, up 1 over 2. Solid line, connect. Shade above. Let's see, where does our shading going to cross? What do you guys think? This one, down to 3. Up 1 over 2, up 1 over 2, up 1 over 2. Broken line. Shade, what does that say about the shading? Shade below. This one is a clear, definite. You guys can see, where does the blue intersect with the red? This is a no solution. Nah, I had this on broken still. No solution because the red and the blue never meet. So I wanted to show you that there could be a special case of no solution. This isn't, the next one I'm about to show you isn't necessarily a special case, but sometimes it looks kind of silly. Like let's say you have two like this, and pretend you're shading here for the blue, and pretend you're shading here for the red. The answer would just be where this purple is, which is, I always think that's a fun little answer when it looks like that. So I just want to let you know, like sometimes the graphs look kind of silly, but remember, it's where the shading overlaps. And if the shading doesn't overlap, there's no solution. I hope that was okay. I know it was a really, really, really quick lesson.